Alright, so we're going to look at what is probably going to be one of the weirdest ideas, concepts that we're going to talk about this year, which is the idea of an imaginary number, okay, which we will kind of build up to it. So first, looking at just this page, and I'll get more into the imaginary stuff when we actually start to see it in the notes, but on this first part, it talks about adding, subtracting, and multiplying polynomials to prepare for operations with complex numbers. So, first, make sure you know what a polynomial it is. What a polynomial is. Essentially, it's really just an equation. Okay? It's just another word for it. It's just polynomial. It can be defined as a trinomial, which means it has three terms, a binomial, which there aren't any here's a binomial. Okay, this would be considered a trinomial. If it just has one term, okay, that's called a monomial. Alright, so you can add these, which you've done these before, probably more times than you've wanted to. But looking at this top problem right there, is that going to affect that second set of parentheses? Is it going to do anything to all that in there? Yes or no? What's it going to do? Do what? No. No. Connor, is that going to do anything to the second polynomial? No. So if I'm adding those two, I just get rid of the parentheses on the second set, and I combine all my like terms. Okay, that's what they're doing, step 1 through 4 here. Alright, going here, if there is a subtraction, if you're taking one polynomial and you're subtracting the other, is that subtraction sign, is that going to affect anything in the second set of parentheses? What is that going to do? That is going to flip the signs. Okay? So you would distribute a negative is what you're doing. So that's going to give you negative 5x squared plus 3x, and then the book has it wrong. It should be plus 6 right there. Alright, so you can add these polynomials. You can subtract these polynomials. Excuse me. Going to the next page, you can multiply polynomials. Okay, so the way I would do this, looking right here, I would do FOIL just kind of to that next degree, I guess. So I would take x and I would distribute it to all three terms, which is kind of what this is setting up to do. I would take the 1, I would distribute it to all three terms, which is what this is doing, and then you're going to combine like terms. Okay, that's just multiplying a binomial, 2 terms, times a trinomial, which is 3 terms. So let's come down here. I'm going to walk through one of those, a multiplication, and then I'm going to have you do one of each. We're not going to do all 6 of these problems here. So look at B. So the first thing I'm going to do, well, before I do it the way that I normally do it, if you want to do this by using the box method, by all means do it. It's just that now, because it's a trinomial, I would set it up with, you would need either 3 columns or 3 rows. I would do 3 columns, and so you've got your x plus 5, you got your 2x squared, minus 3x, minus 4, and you would fill it all in. Okay, but again, I do the distribution, so I would take x times 2x squared, which is going to give me what? 2x cubed. X times negative 3x is going to be what? Negative 3x squared. X times negative 4. Okay. And take notice as to how I organize this second part of this problem. Okay. So now I'm going to distribute the 5 in there. 5 times 2x squared is what?
10x.
10x squared. So I'm going to put that 10x squared underneath the x squared from when I distributed the x. 5 times negative 3x is what?
15x.
Negative 15x. 5 times negative 4 is what? Negative 20. And then I take those, and then that's how I'm going to combine my like terms. Students who have done this in the past, I feel like there's less room for error if you set it up to combine like terms, as opposed to having one really long line of 6 different terms and going through there and matching them up and combining them. Okay, this is already set up to do that. So my 2x cubed is just going to come down. Then I've got negative 3 plus 10. 7x squared. Negative 4 minus 15. And then my negative 20 comes down as well. Okay, your first and last terms are always just going to come down. So I want you to do A, which is an addition. I want you to do C, which is another multiplication. And I want you to do D, which is a subtraction. And then check my answers up here to make sure that I did them correctly. Here's the answer to A. Here's letter C. There's the answer for D. Alright, so let's look at D then. So whenever you're subtracting, all you're going to do, your first polynomial is going to stay the same. And then your second one, you're going to distribute that negative. So everything in my second polynomial, my signs are going to change. And then I'll combine my like terms. So I've got 9 minus 9x to the fourth minus 8x to the fourth. I've got my 2x cubed. I've got my minus x. And then I've got my minus 5. So now we're going to start looking at I. On this part, we're going to talk about why we need it and kind of where it comes from a little bit. So up here it says, so far within this course you have worked within the set of real numbers and determined real number solutions. All that means is all the problems we've had so far, the answers have been real numbers, whether it's positive, negative, zero, a fraction, a repeating decimal, whatever. It says, remember the set of real numbers includes the set of rational and irrational numbers. So on 1 it says, consider the equation x squared equals negative 1. So if I wanted to solve for x there, what would I need to do? Do what? Square root. So I would take the square root of x squared, which just gives me x, and I would take the square root of negative 1, which whenever I want y'all to put the square root of negative 1 in your calculator and tell me what it says. It says what, Jacob?
Error.
It says error. Okay, non-real answer. Thank you for saying that part. So, if it is non-real, then the answer is going to be what we're going to consider imaginary. Okay. So on the question it says, is there a real answer? Obviously it said no. And then it says, explain your answer. Okay, I want you to put that you cannot take the square root of a negative number and get a real solution. And one of the big reasons why you're going to need to know how to deal with this stuff is I believe it's next class. We're going to talk about the quadratic formula. A big part of the quadratic formula is that square root. Okay, and so you're going to have to deal with whenever the number that's underneath the square root becomes negative, you got to know how to handle that. Okay, but another reason, another explanation you could give on this is because you can't take the square root of a negative number. You also can't square a number and get a negative solution. Okay, if you find a way to square any number and get a negative answer, okay, you need to come tell me, and I'm going to retire and I'm going to be filthy rich. Okay, because we would have disproved years and years of math. Alright? Gavin, you can't do it, I promise. Don't try. That was my point I'm trying to get across. So, going down to the next sentence, it says the imaginary number I is a number such that I squared is negative 1. Because no real number exists such that its square is equal to a negative number. The number I is not a part of the real number system. So all that's saying, kind of the explanation where it comes from, is what we set up here. Okay? So if I squared, and these two rules are probably the big part. These are kind of the big idea of today. So if I have that, I squared it equals negative 1. If I solve for I there, what am I going to do? What did I do whenever I solve for x squared up top? Square root. Okay. So what that means is I equals the square root of negative 1. Alright. Now, this I right here, in this sentence, did this say it was an imaginary variable or an imaginary number? Number, right? Okay. So this is not a variable. Alright, here in this world, in this math world, I know that really looks like a letter, and everything you've been taught up to this point says that I is a letter. Okay, but in the math world, that's considered a number. Okay, again, so just being in class, this is probably one of the weirder concepts that we're going to talk about this year. So, coming down here, we're probably not going to go through this whole table, but we're going to walk through this and talk about a pattern of I based on what that exponent is. Okay? So if I have I to the first, that is obviously going to be I. Okay? Now in there, if you want to put, whenever we get into actually dealing with square root stuff, yes, it's also the square root of negative 1, but to find this pattern for this example, we're just going to put I. Okay, so I squared. Okay.
You said the square root of negative 1 in the first one?
Yes, yeah, you can put that in there. Alright, so I squared, we said was what? What did we write up top above this table? It's negative 1. Okay, because if you have I squared, that means you have the square root of negative 1 times the square root of negative 1, which is just going to give you whatever's underneath the square root. Alright, so now we kind of start filling in the pattern starting here. So if I have I cubed, another way I can look at that is saying that I have I squared times I. Alright, you got to kind of know your exponential properties there. We've already said that I squared equals what? Negative 1. And I to the first is just I. And so negative 1 times I is what? Negative what? Okay, so negative I. Alright, there's only one more of these weird things, and we'll kind of start developing the pattern. So if I have I to the fourth, then I've got I squared, which is what? negative 1. And I've got another I squared, which is what? Negative 1. Negative 1 times negative 1 is what? 1. Positive 1. Alright? And guys, there stops the pattern. Over there on the left. Okay? So I could go through this. Alright? And starting with I to the 5th, I would just start this pattern over. Okay? This could be I to the 6th, I to the 7th, I to the 8th. Alright? So we're just going to go through I to the 8th, and I'm just going to kind of explain why that is. And the big idea, whenever you're having to solve to figure out exactly what it equals based on that exponent, groups of 4 is really the key to getting there. Okay, because if I have 1 times whatever, is that really affecting what I'm multiplying 1 by? No, 1 times 7 is going to be 7. Okay, 1 times negative 4 is going to be negative 4. Okay, 1 times dog is dog. Alright, it doesn't matter what I'm multiplying 1 by, it stays the same. So if I have I to the 5th, I've got 1 I to the 4th times I to the 1st. So is that I to the 4th, is that doing anything? Yes or no? What does it become? I to the 4th becomes 1, so the I to the 4th isn't doing anything, and all I'm left with is I, which, like I said, is the same as I to the 1st. Whenever I have I to the 6th, alright, I've got I to the 4th times I squared. I to the 4th isn't doing anything, and I squared equals what? Negative 1. I go to I to the 7th. I've got I to the 4th times I cubed. I to the 4th isn't doing anything. And what does I cubed equal? Negative I. Okay, and so goes the pattern. On the last one, I would get I to the 4th times I to the 4th, which turns into 1 times 1, which is just 1. Alright. Down here, it ends up being the same thing, just a little more drawn out, so we're not going to do that part. But that pattern that you need to kind of see, and I've mentioned, is that the values repeat themselves the values repeat for every 4 powers of I. Okay? So let's now go here. Alright, now at the very bottom of each one of these, I want you to put negative I equals negative I. And I'm going to walk through these. This is 3 different ways to do this, and in all reality, I would do this a completely different way than any of these. Okay, so you've got this first person who, she made this a power to a power. Okay, so she took I to the 4th, and this is probably more similar to the way I'll do it, but I don't set it up this way at all. Alright, she did this a power to a power, and she changed it to I to the 12th, which is the same as I to the 4th to the power of 3. Okay, times I cubed. So that I to the 4th turns into 1 cubed, which is just 1. So again, that pretty much cancels itself out, and you're just looking at I cubed. Okay, and I cubed turns into either one of these. Negative square root of negative 1 or negative I. Alright, this person says, and I don't really like these the way they have it set up, but it says the exponent of I to the 15th is 15. When I divide 15 by 4, I have a remainder of 3. That 3 is going to become my exponent. Okay, so this is, both of them are they're kind of similar to how I'm going to show you. They make it look really weird. So, and we're not going to look at this, because that gives me a headache. So, if I have I to the 15th, because we need to make sure we all remember what a remainder is. Okay? And if you don't remember that, that's the number you used in elementary whenever you didn't want to. Whenever you were learning division, and your elementary teachers didn't want to talk about decimals or fractions and making it, you just needed to learn division. So, if I have 15, again, the key to this is groups of 4. Okay, so 15 divided by 4 is what? Do what?
3.75.
Okay, it's 3 point something, right? Okay, I don't really care what it is. Okay, but if I'm doing this with the remainder, 3 times 4 is what? 12. So I'm going to do 15 minus 12 to get my remainder of 3. We're going to go through a couple more examples of this. So that gets me to the exponent that I need, that remainder. All right, I to the third. You just follow that little key that we made, which gives me negative I. Okay, got that, David?
So you,
We're going to go through a couple more, and I think better examples than this.
so you would, so like after you divide that, since 3 is the remainder.
Yes, that becomes the power of I. Because you want to get it down to I to the first, I to the second, I to the third, or I to the fourth. And that's going to give you your answer. Whether it's I, negative I, 1, or negative 1.
So you multiply the answer that you got.
Yeah, let's walk through a couple more. Maybe it'll make sense after going through these examples. Alright, so let's start off with kind of an easier one. Alright, so let's look at C. It says I to the power of 400. Which looks hard, but it's really the easy one. So I'm going to do 400 divided by 4, which is what? 100. Alright, what that means is I have 100 I to the fourths. Alright, which means I'm multiplying 1 times 1 100 times. Which is going to give me what? 1. So whenever you do this divided by 1, if it comes out evenly, your answer is 1. Okay, that's what it's going to equal. Alright, let's jump up to A. So I'm going to take 93, and I'm going to divide that by 4. So let me throw that in your calculator and tell me what you get. 23?
23.25.
23 point, okay, I don't care. Alright? Because all the decimal tells me is, alright, it's not going to be I to the fourth, it's going to be I to the first, second, or third. And I got to figure out which one. So I'm going to do 93, the original exponent, minus 4 times that 23 that I got. Alright, 4 times 23, that's going to give me 92. And 93 minus 92 is what? 1. And what does I to the first equal? No. Just I. Okay? Now I'll write it like this. I to the first, which is going to give me I. Alright? So again, guys, all you're trying to get it to I to the first, the second, or the third. Because if you divide and it comes out evenly, your answer is 1. Alright, let's just do B. We're not going to do D. So if I do 206 divided by 4, that's going to give me 51 point, I don't care. But it does have a decimal. That's all I care about is, does it have it, does it not? I just don't care what it is. So I'm going to take 206 minus 4 times 51. Okay, so that 4 times 51, that's going to be 204. So 206 minus 204 is 2. So I squared equals what? Negative 1. Questions on that?
So if you
But since we just put that into words, it's probably not a bad idea to put that. Remainder becomes exponent. Okay. So as far as dealing with the powers of I, we're done with that now. We're going to talk about the rest of talking about I is going to be talking about how you're going to deal with it really whenever we get into this quadratic formula. Okay, so it says, now that you know about I, you can rewrite expressions involving negative roots. For any positive real number n, the principal square root of a negative number, negative n, is defined by negative n equals I times the square root of n. All this means, and I think this becomes harder the more you overthink it, if I've got the square root of negative of any number, I don't care what it is, the very first thing I'm going to do is pull an I out, because the square root of negative 1 is I. So I pull that I out of there, and then now I have to simplify that, which we're going to talk about here in just a second. Okay. Now, the book, again, it breaks it down into very little steps. So it broke it down again into that negative 1 and the 75. It took the square root of negative 1 out to give me that I, and then it simplified the radical, the square root of 75 to 5 times the square root of 3. Alright, so let's talk about simplifying radicals. Raise your hand if you know what a radical is. Meredith, what's a radical?
Actually, I don't know.
Okay. Somebody take a guess. What's a radical? Yes, ma'am. No. You're kind of around in the ballpark, but Alvin?
The break number inside the square root.
Kind of, but no. It's a symbol, if that helps you. What was that, Meredith? What did you just do with your finger?
Triangle?
Oh, okay. I thought you were doing this. I thought you were... It's the, as someone in my 3A said, it's the square root thingy. Okay? Which that is exactly what it is. Alright, that is considered a radical. If nothing is written here, then you take the square root of what's underneath there. But if it's a 3, it's the cube root. If it's a 4, it's the 4th root. Okay, the 78th root. However many roots I want to take, I put that little number up there. Alright, but you just don't need to notice that. I mean, in your mind, if you want to think of the radical as that little square root thing, that's fine. But you need to know that just because you see that, it's not always automatically going to be the square root. Because there might be something up in front of it. Now, for this unit, yes, it is going to be square root. So, we're going to talk about simplifying a number that's underneath there. Does anybody remember how to simplify that? Yes?
Which one was that? Like 20?
Let's do this right here. Square root of 32.
You can say you divide by 2, so then it'd be 16 and 2.
Okay. And then
Since 2 can't be divided, you would just circle that one, and you work 16, so 16, or 8 and 2, and so on.
okay. All right. So let me tell you how my mind processes this. And so me drawing that little part up there, does that kind of jog people's memory? That's probably the way you were taught. Okay, and that is one of the most mind-numbing processes that I can go through for me. Okay, because I sit there, and I'm going to show you a different way to do it. So I've got 32. I can divide it by 2 to get 16. I'm going to divide 16 by 2, and then I'm going to get 8. And then I can still divide 8 by 2 and get 4. And then don't write this down. I can divide 4 by 2 and get 2. So now I've got all these 2's, and I'm going to see how many 2's of 2's, pairs of 2's I can get. So I've got one pair of 2, which is 2. Only one 2 that comes out. I've got another pair of 2, which that comes out. But I still have this 2 left over, so I'm going to put that 2 under the square root. And I'm going to multiply those. Okay, you see where I'm getting? It is just awful for me. I don't know about you. If you want to do it that way, awesome. Do it that way. I'm going to show you a little bit shorter way to do this, okay? Now, the only downfall of my way, and I don't think it's big, because it's not hard to come up with, you have got to know what perfect squares are. All right? And this isn't going to be a list of numbers you have to memorize. You just got to remember how to get the list of number, and it's not that hard. Okay? What is 2 squared? 4. What is 3 squared?
9,
4 squared?
16,
5,
25,
6,
36,
7,
29,
8,
64,
9,
84,
10. Okay. Everybody see how I got those? You're counting, but you're just squaring the number. Okay? You're not going to include 1 squared on this. Okay, that's the oddball. That's not going to do anything for you in this process. Okay? So, yes, it does kind of look like a random list of numbers unless you know how we got there, and that's what you need to know how to do. So, what I'm going to do is I'm going to take 32, and I'm going to try to divide that by the largest perfect square possible and still get an even answer. Okay, I don't want to divide it and get 1.789. That's not going to help me. Okay, so if I'm at 32, the first perfect square under 32 is 25. Can I divide 32 by 25 and it come out evenly? No. Can I divide 32 by 16? Yes. So I'm going to take the square root of 32, and I'm going to break that up into 16 times 2. It's the same thing. Right? It's just written differently. 10 is the same as 7 plus 3. It's just written differently. All right? So now that I have that, what is the square root of 16? 4. So I take 4 out and I'm done. Okay? In my mind, obviously it's quicker. A lot of people like to think with the small numbers, so if you like to do the tree, okay, that's fine. Just go buy a 100-pack of notebook paper. Okay? It takes up a lot of space. So, and if you look at how the book did it, that's exactly what they did. They divided 75 by 25. That's the largest perfect square. Took the square root out. How they have this written here, and I told my day I'd go look at this. You're going to see me write that like this right here, unless I come back next class and say, never mind, because I'm going to try to remember to look at some SAT, ACT stuff, and if they use this format, then I'm just going to change how I write it so y'all can get used to seeing that. Looking down at Georgette's work over here. What did they do wrong on this?
The 4 is not supposed to be negative.
Okay, what's the 4 supposed to be?
It wants to be positive.
Okay, what else though? What? Do what?
4i.
Okay, it's supposed to be 4i. So the mistake is the very first step. Okay, which I told you at the very beginning. You take that negative, you pull it out, and you turn it into what? I. Okay? Don't just take the negative out. Okay? And as simple as a step as that is probably the most common mistake that I see. Alright? So we're going to go through a couple of these. We're just going to do A and B on here. So what is nice about the square root of 64 though? It's already a perfect square. So I don't have to simplify it. So I'm going to have 8 minus. Then I've got the square root of negative 63. What do I need to do with that negative? I'll move it outside and turn it into what? I. Then I've got the square root of 63. Need to simplify that because it's not a perfect square. What is the largest perfect square I can divide 63 by? 7's not a perfect square, but what's the other number?
49.
No. 63 divided by 49 is... But that doesn't give me a whole number whenever I divide it. I want to make sure it's a whole number. 9. Okay. 63 divided by 9 is what? 7. So I've got to have both of those numbers down there. Okay, 63 is the same as 9 times 7. And then what is the square root of 9? 3.
That was 9 squared.
So I pull the 3 out. I won't have to simplify the 7 down anymore. Looking at B. What do I need to do with that negative? Pull it out. Can I Can I simplify the square root of 13? Nope. And the only thing we're going to have to adjust here is we're going to put it in this format. The term that has I is always going to be after the other one. Alright, now we've talked about an imaginary number, and it's any kind of number with I attached to it. This A plus BI, and we're going to get to this on the next page, this is what is called complex. Alright, and it's the combination of a real number and an imaginary number. Okay? You're going to see a lot of this format when we get into the quadratic formula. Okay? Because you always, if you remember the quadratic formula, at the beginning you've got negative b plus or minus the square root. So that a is going to come from that number, whatever you put there, and then your I is going to come from that being negative. But we're going to dive into that a lot more next class. Alright, so go ahead and turn to the next page. This page is going to be extremely short. Just going to go through a couple. This kind of talks about the comparison between just the imaginary number and one that is called complex. So you've got the set of imaginary numbers is the set of all numbers written in A plus BI, where A and B are real numbers and B is not equal to 0. A pure imaginary number is just that form of BI. It's got I on it. A complex is A plus BI. Okay, so you don't necessarily have to, well, we're just writing letters down. You can write it down. Alright, so A, is this imaginary, complex, or real? Imaginary. 3, is that imaginary, complex, or real? Real. Negative 5.5216. Real. Pi plus 3.2i. Complex. Okay, pi is a number. Okay, so go ahead and turn to the next page. We're actually going to skip that page and go to 258. So at the very beginning, we were adding and subtracting polynomials and multiplying polynomials. Now we're going to do the exact same thing with I involved. And all the rules apply. Now I told you at the beginning that is I a variable or is I a number? I is a number, okay? And this is where it gets even weirder. But I has some characteristics of variables. Whenever you're combining like terms, you follow those rules. Okay, you can't combine 2 and 3i. But you can combine 2i and 3i. Okay, so looking at that very top, David, that minus in between those two binomials, is that going to affect the second binomial? Yes. It's just going to change the signs. After I change the signs, I just combine like terms. It's exactly the way it was at the beginning, the stuff we're looking at the beginning. So you've got 3 minus 1, which is 2. 2 plus 6, which is 8, I.
The last one.
Yeah, what, how's that? Negative 3i.
Alright, so now going down to the bottom part of this, so now looking at multiplication. So the first one, and this is where that whenever you're multiplying, this is whenever that I squared being negative 1 comes into play. So on A, what am I going to do with that 5i? Distribute. So I've got 5i times 3, which is 15i. I've got 5i times negative 2i, which is negative what? 10i squared. Whenever you run into I squared, the very next step you need to plug in -1 for I squared. Which -10 times -1 is going to give me positive 10. Okay? And I'm going to go ahead and switch those terms so that it's in that A plus BI format. Alright, but that -1 is always going to change the sign of the number it's attached to. Now going over to B, this is where I would do FOIL, or box method if you prefer that. So I've got 5 times 2, which gives me 10. 5 times -3i, which is -15i. 3i times 2, which is 6i. And 3i times -3i, which is -9i squared. So I'm going to combine my like terms, those middle two, to get -9i. And then I'm going to plug -1 in for I squared as well.
It would just be 10.
Pardon?
It would just be 10.
No. 19 minus 9i. Because that's going to come to 10 minus 9i plus 9. And then I combine the 10 and the 9. Next, I want you to do C and E. Here's their answer to E.
The signs are different in each.
Okay, the signs are different, and the numbers are what? The same. Alright, in 5, or sorry, not 5, in C, I've got 2 plus I and 2 minus I. E, I've got 3 plus 2 and 3 minus 2. D's 1/2 plus 1I, 1/2 minus 1, okay? So it's all the same numbers. So whenever you notice that you have something in this format, A plus BI and A minus BI, which you're going to have using the quadratic formula, you can do A squared plus B squared to get your answer. Alright, so let's look at F. My A is 1, my B is 3. Okay, 1 squared is 1, 3 squared is 9, 1 plus 9 is what? 10. Let's look at the 2 that y'all already did. What is 2 squared? 4. What's 1 squared?
1,
4 plus 1 is 5. What's 3 squared?
9,
What's 2 squared?
4.
9 plus 4 is 13. Okay? And the other one would be 1.25. You did it. Alright? So that's just kind of a short, easy way that you can do that. Going to, I think this is going to be the last part we're going to talk about here. And it's really just coming down to this last, well, we'll talk about the last 2 paragraphs here. So it says, a polynomial in one variable is an expression in the form a sub 0, a sub 1 of x, a sub 2, okay, and that's just differentiating the different kinds of terms. Something without x, something with x, something with x squared, something with x cubed. All those are different kinds of terms. Okay? Where the coefficients are complex numbers, real or imaginary, and the exponents are non-negative. A polynomial can have a special name according to the number of terms it contains. A polynomial with one term, and I kind of mentioned these at the beginning of class. 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and so on. Okay, so we're going to go through these examples down here. And once again, the I is going to throw a kink into all of our, just into the whole math world. It says identify each expression as a monomial, binomial, trinomial, or something other than that. Okay, so I, which is a number, not a variable, So that's kind of that rule plays into this. All right. So 3 is obviously a number. 5i, is that a number or does that have a variable on it? It's a number. So is this a monomial or a binomial? It's a monomial because they're all numbers. Okay? And really what you're kind of looking for, how many different kinds of terms do you have? Those are both numbers. Alright? Coming over here, and a good rule of thumb really is if you're identifying these, you can just kind of ignore the i's. And that makes it all pretty simple. So, would we consider these two terms the same? Even though we can't combine them, do we consider them the same?
Yes.
Yes, they just have x. Are these two the same?
Yes.
Yes. So I have 2 different kinds of terms. So this would be a what? Binomial. C would be considered a what? Monomial. It's got that I in there, but that doesn't mean anything other than we just can't combine it. D would be a what? Trinomial, because you got your x cubed, you got your x, and then you just got your number.